You know how your phone just knows your face, or a self-driving car can spot a stop sign? I mean, it really feels like magic, right? But it's not. Today, we're going to pull back the curtain and show you exactly how this incredible technology works, how computers actually learn to see. Okay, so take a look at this. You know what it is instantly. It's a dog, a pug, right? You don't even have to think about it. Your brain just sees the floppy ears, the smushed up face, and it all just clicks. Effortless. But for a computer, it's a whole other ballgame. It doesn't have a brain. It doesn't have memories of playing with dogs. It just has data. So how does it possibly go from a bunch of ones and zeros to knowing that's a pug? Well, that's the big question we're going to break down. To get it, we have to start at the very beginning. We have to understand how a computer sees in the first place. And for a machine, everything, and I mean everything, starts with the pixel. See, here's the thing you got to wrap your head around. A computer doesn't see a dog or a face. It just sees a giant grid of numbers. That's it. Each number is just a code for the color of one tiny dot. To the computer, this image is just a meaningless spreadsheet. So the first obvious thought people had was, okay, let's just connect every single one of those pixels to a brain cell in our AI. This is kind of the old brute force way, and as you can guess, it's a complete and total mess. But there's a much, much smarter way. Instead of looking at everything all at once, you start by looking for simple little patterns. You build up. And just how messy is that old way? Well, get this, for just one layer of a network looking at a tiny little image, you'd need this many connections, or parameters. Over 300,000. It's astronomically huge and wildly inefficient. Now, let's look at the smart way. Using this new approach, called a convolutional neural network, or a CNN, that number plummets to just over 1,700. That's not a typo. It's over 175 times more efficient. So what on earth is the secret? How does it do that? Well, that incredible efficiency comes from a really brilliant, but actually very simple shift in thinking. The secret is all about learning to see locally. Here it is, the core idea. Instead of trying to understand the entire, overwhelming picture all at once, a CNN breaks the problem down into tiny, manageable chunks. The secret is to think locally, not globally. And the way it does this is with something called a local receptive field. Now that sounds technical, but the idea is super simple. Just imagine that each neuron or brain cell in the network is only allowed to look at the image through a tiny little peephole. It's not responsible for the whole thing, just one little patch. Okay, to make this crystal clear, let's use an analogy. Let's pretend our AI network is actually a team of highly specialized detectives. We're going to call them the feature inspectors. Now, every inspector on this team is a super specialist. They have one and only one job to do. In the real world of CNNs, we call these inspectors filters. So you might have one inspector whose only job in life is to find vertical lines. Another one is an expert at spotting curves. And a third one, all it does is look for the color green. And here's what they do. Each inspector takes out their little magnifying glass, remember, that's our local receptive field, and they methodically scan it across the entire image, one little square at a time. And every single time it sees the one thing it's looking for, a vertical line, that curve, that patch of green, it gets really excited and basically shouts, "Aha!" and makes a note of where it found it. What it's really doing is creating a little treasure map for its one specific feature. But remember, we don't just have one inspector, we have a whole team of them. So after they're all done, we end up with a whole stack of these treasure maps. The official term is an activation map, and each one is a simple grid that highlights exactly where in the image its one special feature was found. Okay, so we found some lines and some colors. So what? That seems like a pretty long way from identifying a pug. Well, this is where that clever hierarchy comes in. This is where the magic happens, as we go from simple lines to actual life forms. Think of it like building with Legos. The very first layer of inspectors finds the simplest, most basic pieces, the little edges and colors. Then, the next layer of the network doesn't look at the original image, it looks at those maps, and it learns to combine them into textures like fur or wrinkles. Then, an even higher layer takes those patterns and assembles them into things we recognize, like an eye or a nose. And this visualization shows it perfectly. Look way over on the left, the first layers are just seeing simple lines and color blobs. But as you move across to the right, you can see those simple things start combining to form complex textures. And by the time you get to the far right, Boom, you can actually see things that look like eyes and snouts taking shape. The network is literally building its understanding from scratch, right in front of us. All right, so our network has done all this amazing detective work. It's extracted all this information, from simple lines to textures to parts of a face. But now, how does it all come together to make the final call? This diagram lays out the whole assembly line. That whole complicated part on the left, that's the feature extraction we've been talking about. That's our team of inspectors doing their thing. Once they're done, all their reports, all the evidence, gets passed up the chain of command to the chief. Now, this chief is technically called a fully connected layer. Its job is to look at all the high-level reports from the inspectors, all the activation maps that are screaming, "We found fur here," or "We detected floppy ears over here," and it weighs all of that evidence together to make the final decision. And after considering everything it's been shown, from the tiniest edges to the most complex patterns, it comes to a conclusion. Based on all the evidence, case closed. It's a pug. So if you take one thing away from this, let it be this. Convolutional neural networks build understanding in layers. It's a lot like how we learn. They start with incredibly simple patterns and assemble them into bigger, more complex ideas. And this hierarchical approach, that is the fundamental breakthrough that finally allows machines to make sense of our messy visual world. So there you have it. We've just walked through how a computer learns to recognize a dog. But that really just opens up a much bigger question for all of us to think about. Now that we've given computers this incredible ability to see, what should we teach them to look for next?